Welcome friends. Let us solve another interesting question on complex numbers, and the question is as follows. Let alpha and beta are different complex numbers with mod beta is equals to 1. Then find mod of beta minus alpha over 1 minus alpha bar into beta. So let us see how to solve it. We shall apply the result that square of mod beta minus alpha over 1 minus alpha bar into beta, which is equals to beta minus alpha over 1 minus alpha bar beta, and conjugate of whole value beta minus alpha over 1 minus alpha conjugate into beta, like this. Then this value will be beta minus alpha over 1 minus alpha conjugate beta into conjugate of beta minus conjugate of alpha, and then this value will be 1 minus conjugate alpha and beta conjugate, and then this value will be beta minus alpha into beta conjugate minus alpha conjugate, and here it will be 1 minus alpha conjugate into beta, and here is 1 minus alpha into beta conjugate. And now we shall multiply these values in numerator and denominator. Then we get beta into beta conjugate minus alpha conjugate beta, and here is minus alpha into beta conjugate, and here is alpha into alpha conjugate. If we multiply in denominator, then we get 1 minus alpha into beta conjugate minus alpha conjugate into beta, and plus alpha into alpha conjugate beta into beta conjugate, and this value will be square of mod beta, and here is minus alpha conjugate into beta, here is minus alpha into beta conjugate, and here is square of mod alpha. Here is 1 minus alpha into beta conjugate minus alpha conjugate into beta, and this value is square of mod alpha into square of mod beta, and we are given that mod beta is equals to 1. Then this value will be 1 square means 1 minus alpha conjugate into beta minus alpha into beta conjugate, and here is mod alpha square. Same as here we have 1 minus alpha conjugate beta minus alpha into beta conjugate, and here is same mod alpha square. So this value is equals to 1. Therefore mod beta minus alpha over 1 minus alpha conjugate beta is equals to 1. So this is the solution of the question. Thank you.